Hello students, today we are going to see about how to develop a home monitoring application based on IoT. In last session, we saw about how to control a LED over Wi-Fi network. We are going to extend that experiment to control our home appliances. I am making a connection at BCM 17 pin. At other end of the wire, I am connecting a resistor with value of 1 kilo ohm. I am going to design a driving circuit using BC547 transistor. BC547 has 3 legs: emitter, base, collector. When you hold this transistor, keeping the flat surface towards you, pins will be emitter, base and collector. I am connecting base terminal at resistor point. Emitter terminal of the transistor should go to ground pin of Raspberry Pi. I am going to use a 5 volt relay to control home appliances. 5 volt relay has 5 pins. These 2 pins are called as coil pins. These 3 pins are NC, NO and common. In coil pins, will give 5 volt to activate the coil and deactivate the coil. These pins will be connected to Raspberry Pi through some driving circuit. Here our driving circuit is designed using BC547 transistor. These 3 pins NC, NO and common pins are used to connect our home appliances circuit. I have interfaced 5 volt relay on breadboard. I am connecting collector pin of transistor to one pin of coil of relay. I am connecting other coil pin of 5 volt relay to 5 volt of Raspberry Pi. I am connecting one diode in this circuit. I am connecting cathode side of diode with 5 volt supply. Anode side of diode should go to collector terminal of BC547. Now my connections are over. Home appliance connection is left. Let's check whether this circuit is working or not. When you click on and off buttons in your web page, you should get tick sound from relay. If you get tick sound from relay, this connection is working perfectly. We are getting tick sound, so we can proceed for interfacing our home appliances with the NC NO common pins of relay. I am going to interface one CFL lamp with this circuit. I have cut wire like this. One point of CFL lamp will go to NO or NC point of relay. Another point of CFL lamp will go to common pin of relay. This lamp has one provision to connect with our EB plug points. I am connecting this plug at extension cord. This is our total setup. From BCM 17, I have connected one 1 kilo ohm resistor. That resistor is going to base of BC547 transistor. Emitter terminal of BC547 is going to ground point. Collector terminal of BC547 is going to coil of 5 volt relay. Another coil point is going to 5 volt of Raspberry Pi. One diode is being used between coil pins. Cathode point of diode is connected to 5 volt supply. Anode point of diode is going to collector terminal of BC547. I have connected one CFL lamp across NC point of relay and common point of relay. This CFL lamp has one plug. I have connected that plug at EB power supply. Now let us check whether our experiment is working or not. You can control this lamp from any devices connected with your local area network, even from mobile devices, but device should be within your Wi-Fi range. If you want to control this lamp from your mobile device, connect to the local Wi-Fi network at your mobile and check whether this connection is working perfectly or not. Then type the IP address of the Raspberry Pi in your browser. For example, in my case, IP address of the Raspberry Pi is 192.168.2.8. I am giving that. So our web page will open with two buttons, on button and off button. If you press on button, the light will get switched on. If you press off button, the light will get switched off. You can control your light from this mobile device. You can switch on and switch off from your mobile. This is a basic example of IoT application which can be developed based on Raspberry Pi. Thank you.